Hi, in this video we are going to see how to identify a primary key and non-primary key in functional dependency and normalization. So basically a primary key it notes that if an attribute that is a part of any candidate key, then a non-primary attribute is defined as if an attribute that is not a part of any candidate key. So this is the basic definition of primary key attribute and non-primary attribute. So let us take an example of functional dependency, how to find a primary and non-primary attributes. So this is a given example and this is the functional dependency for our problem. So first of all we want to find out a closure property for each and every attribute. For that we need to use a closure to find a set of attributes that can be determined by a given set. So basically we want to identify an closure property for each and every attribute and the combination or the subset of each attribute in my given relations. So let me start from a single attribute, a closure. So a closure is denoted by a plus symbol and attribute is A. So a closure is A plus. So first thing, if it is a closure, that particular attribute must be available there. So here it is an A, so A is compulsory, then A derives B, so that here it is a B, and then check whether AB derives anything, nothing, so a closure of A is AB. Next, a closure of B plus, so closure of B plus is first the attribute itself, so that is B, then if B derives anything, nothing, so one and only B. Next, for C closure, so that is C plus, so first of all that particular attribute, so C, then want to check whether the C derives anything, is the C derives the function F, so CF, and want to check whether the CF determine any other thing, nothing, so the closure of C plus is C and F. Then the closure of D plus, D itself, and D is deriving nothing, so one and only D. Next, for closure of E plus, E. Next, the closure of E, then the E derives A, so A, so D derives A, so A. Next, A, E and A derives anything? Yes, A is deriving B, so here A is deriving B, so finally is EAB. So the closure of E is EAB. Likewise we want to find for F, and finally how we are saying that it is a primary attribute mean for whatever the attribute we are finding a closure, the right hand side term should be an complete attribute of my relation, then only we can say that is a primary attribute. Okay, so still now there is no primary attribute of any combination, so let us move for the next combination, that is A combination. So AB, AC, AD, AE, AF, like that we want to find a closure for each and every term. So AB, we already said that for any closure particular term must be available on my right hand side, so AB, so AB is compulsory on my right hand side. If AB derives anything, nothing, so one and only AB. Next we want to check for AC, here AC is compulsory on my right hand, so AC, and we want to check whether AC derives anything, SC derives F and A derives B, so F and B, and want to check whether AC BF derives anything, no, nothing, so one and only AC and BF. Likewise we want to identify for AD, AE and AF. Next, the B combination. So B combination, the remaining attributes are BC, so BC, BD, BF. So the previous combination as it is BC, so that particular BC must, and whether the BC derives anything, yes, C derives F, so C derives F. So the final closure property of my BC is BCF. Likewise we want to identify a closure of BF and BD. Next we want to identify a closure of C combination, that is a subset of C, so CD, CE, CF likewise. So CD, So we already said that inside attribute, the closure of any attribute, it is must on my right hand. So CD, so CD, and want to check whether the CD determines any attributes in my functional dependency. Yes, C determines F, so C determines F. And finally we want to check whether CDF determines anything. Nothing, one and only CDF. Likewise for CE, so the CE, the attribute closure of my CE is must, so CE. Then want to determine, check whether it determines anything. Yes, C determines F, so C determines F. And E determines A, so E determines A. And want to check whether CEAF determines anything. Yes, here A determines B, so A determines B. And whether we want to check whether this A, B, C, E, F determine anything. Yes, one more thing is here, that is EC. Hence the combination of this two EC determines D. So here this is the first set of relation that we are getting all the combination of my relation. So hence this is called as a super key, and this CE is called as a primary key or candidate key for my given relation. Likewise, we want to find all the combinations of my attributes. If we get any super key combination like this, then that particular attribute is called as also called as a primary key. Let us check for the remaining combinations also. CF, for CF determines CF. Whether its CF determines anything? No, only CF. Okay. Next, the closure properties of D, DE and DF. Likewise, we want to identify a closure property of E. The closure property of E, the subset of E is EF. So EF, the closure property of EF is EF, and E determines A determines B. So EF AB. So next, subset of my relation AB. So AB, ABC, ABD, ABE. Likewise. So for ABC, ABC is must. Whether ABC determines anything, yes, C determines F, so F. A determines B, already B is available, so no problem. So ABCF. Likewise, we want to find for ABD, ABE. Next, the closure of AC. So the subset of ACs, that is ACD, ACE and ACF. We want to identify closure properties. Like the next subset is AD. So the subset of AD combination is AE. And the next is ABC combination, that is ABCD, ABCE and ABCF. So next, the combinations of ABD. So the remaining combinations are ABF, CD. So these are the remaining combination of my given relation. So we want to identify a closure property for all these combinations. If we get any closure property attribute, the relation is A, B, C, D, E, F, then that particular right hand side is called as super key and the left hand side is called as a primary key. For this problem, we have one, for this problem, we are identified only CE as my primary attribute. So CE is my candidate key. Hence, we finalize for this relation, the prime attribute is CE. Thank you.